and let's start. So now we are going to discuss the LO3, be able to design a database system. Yeah. So database system, let me quickly go to the specs. So unit specification is the LO3 includes the design fundamentals and database documentation and database evolution. So we have already completed the database, understand the database design and database management systems, and the third one is also related with the database design, but little bit towards the implementation. And obviously the unit is being taught at the level of a kind of, the theoretical level, so that you should be able to understand all the concepts, very well. Yeah. Now,
yes.
Okay, go ahead.
Now the PPT. Yeah.
Yes.
Relational database design and design fundamentals. So we will be discussing about the design fundamentals in a database. A well-designed database is a prerequisite for fast data retrieval and updates. Now, if you want to design a database, then if you have not designed it well, what do you mean by the design? Can you explain what is meant by the design? Anyone?
Yeah, so the design is pretty much like, if you're talking about a database, like you design meaning like, I would say that, the more options you have in a database, like you have more information, and then that's like the better design it will be. So if I have like only one kind of information, there's not much of a design right there. And also like database, like you can just like key in like anything, like people's first name, and the first name, last name will come out, and then you have everything of your details. So
what do you mean by the more options?
What?
I think design is related to the coordination between the resources we have and the requirements we decided.
Okay. Okay, let me, explain a bit more. Like one of the, parameter that you should implement according to the requirement, that's the specification. But designing is basically, you should have the number of tables, very well, organized, yeah, regarding their structure. For example, what storage they need. For example, if you want to store only, let's say, a 9-digit, let's say, phone number, yeah, and if you are using, let's say, 50-digit space, yeah, then would it be a better design?
No.
No. Like for example, if you have a, attached bathroom in your room, and attached bathroom is, half of the room size, then would it be better to have a, that much bigger bathroom? No. So design wise, number of tables, their relationships, yeah, their storage details, if you want your data to be retrieved very well, yeah, then you need to look at its architecture optimized. So that's mean by the design fundamental. And obviously more options, like Rishwan said, is possible, but more options, would not be a kind of more appropriate answer to the design. Design is that, how, let's say, before you build the tables and other objects that will make your system, it is important to take a time to design it. A good design is a key stone to creating a system that does what you want to do it effectively, accurately, and efficiently. Yeah. So, for example, if you are creating any bridge, yeah, then bridge would have been, designed first. So what I want to explain to you, never, consider designing is implementation. Yeah, design is how
Yes.
do you architecturally make a model that would be implemented. So that's basically the thing I wanted to explain. So basic steps in designing a database normally is, so before, how you would better design, you determine the purpose of your system. If you are very well, known to your purpose of the database, then you can design a better system. Otherwise, if you don't know the purpose very well, why you are designing, then it would not, help. To determine the tables you need in the system, yeah, that's also most important. Maybe if you didn't think about the number of tables, probably, you did number of tables maybe too many, you did number of tables maybe too short, then it would not be a better design. But think realistically what you want and what the system needs. Then determine the fields you need in the tables. Obviously, the fields and columns you cannot add extra, you cannot add limited one, but you need to work really smarter. Yeah, identify the
Yes.
fields with a unique values. Yeah, we should also be able to identify that how you would be, your tables would be identified, which attributes, like, if it is an employee, and how you would be retrieving the data information of an employee, probably with a unique, employee number. Yeah, then
Yes.
how the tables would be, connected, the relationships between those tables, which tables need to be connected, which tables need not to be connected. That's a really, uh, matter of efficiency. Then refine the design. Whatsoever you have the design, you try to refine it. It might need, might optimize it. Why sometime what happens that every databases they claim, yeah, that they are faster. Maybe, for example, there are 100 records, and if you want to, let's say there are 100, employees in a database. If you wanted one record, yeah, from the database, then literally what happens, it's not a magic that, the database would give you the, a record, but the database needs to traverse to every record. Let's say, for example, employee number 50, then really depends on the storage technique. The database need to bypass 1, 2, 3, 4, 5 records, and once it will reach to the record number 50, then it will give you the data. Make sense?
Yes.
Yeah. And if you know the number directly, that employee number is, let's say, 50, then probably it would be faster. But if you are required to find the, let's say there are 100 employees record, and one of the employee has got, the salary very low, for example 10,000 a month, and rest of the employees, 99 employees, take the salary more than 10,000. So assume that how the database will know that the employee who's getting, the 10,000 salary or low would be on particular row number. The database would never know that at what, row it is. The database would need to search all of 100 records. Make sense?
Yeah.
Yeah. So it
Yeah.
really depends on the design, that how well you have created the table, and efficiency matters. If your database is, not designed well, then probably, let's say, out of 100 records, you get, the result, within microseconds. You never notice that computer made you wait. Okay. But if it was a search from 100, let's say a million record, yeah, then probably the lowest salary employed person out of a million records could take, let's say, 5 minutes, depending on the computer efficiency. So you really need to consider the design, and the design is focused on how many things. Like most of things, you need to know the number of tables, the fields, their unique values, their relationships. If everything is fine, then it means you can do well. Is it? Yeah, makes sense?
Yes. Yes.
Reshma?
Yes.
Okay, good. So let us move to the next slide. Now, so let us look at the certain design fundamentals. So how you would be creating the design? Obviously, you need to design according to some modeling. Yeah, like building, you must have heard about the architects who draw the architectures of the buildings. You must have heard about it, isn't it?
Yes.
Yeah.
Yes.
And then similarly in the database, yeah, you draw your architecture, the design of the database using the entity relationship diagrams. Yeah, is a graphical representation of an information that shows the relationship between people, objects, places, concepts, or events within the system. Make sense? Yeah. Three main components of the ERD are the entities. The entity, for example, would be the noun. A noun or an entity, yeah, which could be any object. Let's say student, yeah, teacher, college. They are the entities, yeah. Then there would be the relationships in between them. For example, there is a course and there is the student. What would be the relationship between the course and student? That the student enrolls into the course. Yeah, that is a relationship. How many times? Let's say, for example, one time. So the relationships, is one of the main component of the ERD, and the third is the cardinality. Yeah, the cardinality is how many times. So first you find the entity, then you find that you need to create the relationship in between, and then you need to define that how many times which entity would be related with another entity in which cardinality, means in which number. Like one student can enroll maybe more courses. If you recall, we had discussed the relationships already in the last lecture. Yeah, so it's about them. Yeah, so ERD is the entity relationship diagram. And normally how do you represent? So you can represent like this. This is an entity and there are certain relationships in between them, and you try to explain, you try to illustrate the design of the system. For example, if you needed, let's say, if you needed like 4 or 5 entities, so these are the 5 entities, yeah, and then you will be creating your design. This looks like into the relation, and then you create the tables according to them, and then you define the keys on them, and you are done with this the design. This is a one mandatory a picture. 1 second, let me reply to Raman. Okay, sorry. So is that clear now that ERD is one of the fundamental diagram language? Yeah, let us go to the next. Now what symbols you would be using into the ERD, like entity, weak entity, relationship. Now how you would be representing those entities or symbols like this. You should be able to have a look here. ERD symbols like entity, you represent the entity with this rectangle, yeah. Weak entity with this, double rectangle. Relationship with the diamond, yeah. Then attribute with this oval, yeah. Key attribute, you underline this attribute, yeah. So, and the participations are cardinality. The cardinality, the how many number times? That could be 1, 1 to 1, 1 to 0 to many, 0 to none, yeah. Then 1 to many, and these are, the kind of cardinalities, yeah. So, all your database design should be able to use, these symbols. Maybe at the basic level you would be using few of them, but these are the variety of the symbols that are used, proposed, yeah. And you need to look at into the detail. Maybe at the enterprise level and more advanced level you could use all of them, yeah. Then once you know that how the tables would be connected to each other, yeah, then you need to define the flow in between them, yeah. You need to define the flow, that in what way they would be passing the data. That's also another important artifact of the database design, yeah. For example, if you design an architecture of a building, and you have got 5 rooms and all of the rooms got a attached bathroom, yeah. And would it be sensible to take the drainage of each bathroom to the main line outside the house? No. Probably you could have the internal main pipe inside the house, and by the distance the nearest to from the rooms, you could drain to the inside house main line, and the one main line could drain to the water or whatsoever to the outside the house into the main gutter. Make sense? Yeah. The same way, the data flow diagram allows you to decide that who will be passing the information to and from. So how, like a user needs to put the order, yeah, into another entity, which is the process order entity, yeah. And the process order entity needs to further go to the invoices. That process order needs to create with an entity. An entity is what? Entity, it could be the table, yeah. And then orders, then the users, yeah, would be the entity. And then collect payment could be the another entity in the form of tables. Then fulfillment, shipment, and in this way you can create the interaction between them, which is called the data flow diagrams. Make sense?
Yes, okay.
Okay. So data flow diagrams could have these symbols, like maybe many more, like you represent the external entity like this, process with the circle, data store with this half, the data flow using the arrow, yeah. Now, database development review, yeah. Once you think that you have to design a database, you have in front of you have the database design in front of you, you have everything in front of you, yeah. Then how you can make sure the things are right, yeah, for the purpose of efficiency, effectiveness, and accuracy. So in the design review, all aspects of the database and application code are reviewed for what? Efficiency, effectiveness, and accuracy. You must remember that we review the things by the passage of time, isn't it?
Yeah.
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 So review would help you to know the things, how the things are doing, are they doing well or not. So there are 7 basic design review phases of a database application. Like you review at the conceptual level, yeah, you review at the logical level, you review at the physical level, you review at the organizational level, you review at the SQL and application level, you review before implementation, you review after implementation. Do you get that? You understand by
Yeah.
looking at the listing, and you can process, run your mind that what they are about. You get it?
Yeah.
Yeah.
Yes.
Conceptually review, you logically review, you physically review, you look according to the organization, you think about that how that can be implemented. You think if it is implemented, then is it implemented well? Are they good enough?
Uh,
They are, they are,
Implementation
they are kind of recommended one. Yeah, good
okay.
or bad, it may not apply to you or me, but these are the certain concerns at the moment they needs to be considered. Yeah. So let us see how they have been explained. So in the conceptual design review, it validates the application concept. Yeah. What it does,
Yes.
it design at the conceptual level, it validates the application concept. It involves a presentation of the statement of the purpose as well as a general overview of the desired functionality that will be provided by the application. For example, uh, if you need to create one static website, yeah, that only needs to display a little information about a company, yeah, for example, and okay, for example, the number of branches, what they do, yeah, and that's it, and the phone number, yeah. And if someone is a database designer, yeah, or the company is asking you to have a big database, like a very expensive database for your particular website, do you think would it be viable to spend that much money on the database, however there is no need of the database? Like different hostings, they give you an opportunity, an option to buy the database capacity. For example, one hosting says that the database, let's say 60 GB database is included. Yeah, if you are not using the database in your application, or if you are using, or if you only need, let's say 20 MB for your database, would it be fine to buy that much 60 GB database capability hosting? Which one?
No.
Would it be fine to buy that much extra database?
If requirement is 100 MB and
No, obviously. Yeah, obviously. So the application concept in this way probably would be useless. Yeah. So at the concept review, you try to explore these kind of things. Whether your concept is fine for that particular thing or not. Make sense?
Yes.
Okay. Then logical design review. A thorough review of all data elements, descriptions, relationships should occur during the logical design view. Yeah, you may look at the bold what I am reading. So in logically you could look at the thorough review of what elements you have, descriptions you have, and relationships you see. Probably you might selected 100 of the tables, but you think that are the 100 tables required? Maybe no. You could reduce it. So thoroughly all elements description could be reviewed at the logical review. Then physical review. Yeah. In the physical review, the database is reviewed in all detail to ensure that all of the proper database parameter setting and other physical design choices are made, that a proper translation from a logical model to a physical database was made, and that all the normalization decisions were formally documented. Now, if the logically you need, the let's say student number with the possibly you could increase up to 1,000 students, and the 1,000 student number, let's say, would hardly occupy, let's say, 1 byte of data storage. Yeah, 1 byte of storage into one column. Yeah, and you created a database physically. Yeah, and you allocated the space to student number, let's say 8 data bytes and 8 bytes. And so what would happen, every time your 7 bytes in one record would be wasted, isn't it?
Yeah.
Right.
Yeah. So physically you need to review, you need to ensure that database parameters and every physical design choice that you made, the selection of the data type, storage, database setting, is a proper translation from the logical model is being made well or not. There could be many possibilities that the logical design you have, yeah, and the physical design you created, probably either it is created automatically or you created manually, but you could waste lots of resources, isn't it?
Yes.
Yeah.
Normally if you're,
Unnecessary.
yeah,
It is unnecessary use of resources, and
yeah,
for the security reason we have to kill it.
yeah. The security is also one of the concern, but for example, if your 100 employees needed, let's say, 100 MB, and you are creating occupying the space of 300 employees, yeah, then at the end what would happen, you would run out the allocated space. Yeah, and it's normally the storage sizes nowadays are in GBs and TBs, in terabytes. Yeah, but they are not cheap.
Yeah.
Yeah? For a company wise, every single misuse of the data of the data allowance, it would cost the company double, isn't it?
Yep.
Yeah.
Yeah, so you need to take care of it. Next is organizational design review, to examine the impact of the new application upon the organization from a business and technological perspective. So how the application will help to the organization from the technical point of view, from the business perspective, would it give benefit to the the company or not? So you think about it from the organization point of view as well. Yeah. Then SQL design review. The SQL is the structured query language, a rigorous statement by statement review of the every SQL statement in the application with an eye toward accuracy and performance. Have you done any SQL, got a chance to do SQL?
No.
This
Not
one?
really about that, actually.
Basically, the SQL is the structured query language. Whatever the number of tables you created, yeah, then you inquire from the database. Let's say select asterisk from employees. Yeah, what it would do, that would give you a table of employees, and all the rows and columns, all the records, from the database. Then probably you every time you will not need the all the records from employee. Probably you need a little, few more, only one or two, maybe three, fields. Isn't it?
That's right.
Yeah. But probably, so if you are doing, not queries are not well, then you would be wasting your memory, right? Let's say there are 10,000 records, yeah, into employees, and in each employee there are, let's say, uh, 20 fields. Then how many fields you would be getting if you say asterisk from asterisk is means all, yeah. So probably you would be getting 10,000 multiplied by 20 records. But if you say select salary from employees, yeah, then you will not be getting the 20 columns. You would be only getting only one column, yeah. So there are lots of chances that you could overburden the database if you did the wrong SQL statements. Make sense?
Yes.
So whenever you write the SQL statement, you look at the statement rigorously, statement by statement, manually, with an eye, yeah, to know whether you need the things or not. Because computer will not mind that if you are asking all the records, yeah, it would ultimately put the burden on the processor. It would ultimately put the burden on the RAM, and your processing would become slow. You never notice, if you are dealing with the 100 employee database. But if you are working in an organization, if it is an enterprise organization, if you are given the chance to create a database, let's say for 1,000 employees, and if you did this kind of mistake, then it would cost you the time and the resource misutilization. Yeah, probably your one query on 100 records of a database could give you instant reply. But if it's a 1,000 and employee database, then it would make you wait for 3, 4, 5, 10 seconds to give you the result. And 10 seconds in an enterprise database is not acceptable. You cannot accept it. Make sense or not?
Yes.
Would you accept? So SQL is one of the core design review. Yeah. Then pre-implementation review, an overall review of the system components prior to implementation, post-implementation, to determine if the application is meeting its objectives. Yeah. If it meets the objectives, then you are done. Your review is good. Yeah. Self-explanatory. Yeah. Now, the documentation. You must have heard about the documentation of everything, like a documentation of software, or instruction manual of a device, an electronic device, any other instruction manual of the car. Have you ever found or got a chance to look at any manual?
Yes,
For anything. Even you buy a kettle, you get an instruction, a leaflet that this is the voltage and these things, isn't it?
Yes, yes.
So the database documentation ensures that organizational schema, data objects, and other related information are captured for future reference. Obviously, instructions are given to you for future whenever you use. This documentation often takes many forms, including data dictionary, database administrator guide, database architecture documentation, and database functional specification. So what does the database documentation include? most of the time data dictionary, the guide for the administrators, the architectural documentation, functional specification. So most of the time the data dictionary is used to refer to the database documentation. Yeah. So that documentation is helpful for the database architects, developers, administrators, production support staff, quality assurance staff, and many more wherever you need it. Make sense?
That makes sense.
Now, let me give you an example. You created a wonderful better database, for your company. Yeah. You are the database designer, developer, and at the front end, yeah, the front end they could use anywhere. For example, if you look at the database of an airline, the Emirates, yeah, then Emirates airline, it has got a database. They have well defined the schedules and connections of their, let's say, hundreds and thousands of the airlines. Yeah, they fly from let's say from Dubai to USA and another a corner of the world to Australia or New Zealand, for example. Yeah, their database is fixed. And what happens, the Google or the other travel agents, what they do, they try to get the prices of those schedules, yeah, or airlines, on their own. Have you noticed? Then everybody, every time you ask an agent, they give you the same information, which information the Emirates or any other way, airline has already got. Am I right?
Right.
Yeah. So how they do? Their database, is designed well, and the Emirates, company itself, they distribute their documentation, their database to be contacted, connected, and without any hassle, without any problem, easy to be accessed. But how they know? Obviously, their developers, those developers who design the database of an airline, Emirates, they will not be helping to other, developers, the agents. Would they be helping and connecting to the other developers? Do you think? No. Worldwide, anyone who tries to access their database, they would be looking at their documentation at all. Is that very much clear now?
Right.
Yeah.
Yeah. So in that way, the if you want your database to be accessed to anyone, then you need to create the documentation very well, and that's the main purpose of the documentation. Is that clear now? Yeah. Furthermore, a data dictionary is a dictionary about the data we store in the database. It contains all the information about data objects. What is stored? It's like storing all up-to-date information about the objects like tables, column, indexes, constants, and functions. So, for example, Emirates Airline database has all this information. They would tell you, their documentation would tell you that how many tables are there, how many columns are there, and how you can, connect with their database, and what queries you should be able to make in order to inquire with their database. Are you able to understand technically how various websites are getting connected? Yeah? Have you heard about the term web service?
Of course.
Yeah?
Yes.
So these web services are, connected with each other using these data dictionaries, using certain models. Yeah? Whoever want to be a part of a website, like, Hotel Trivago, you must have heard this,
Yeah.
advertisement, in India, and, like a booking.com. Yeah? How they really, yeah, how they are really give you an exact, pricing and every detail, from that particular specific, website. Yeah, it's all depending on their structure. They have created a database, and it's not a magic. Everybody would be thinking how it is same, but the way they have created the databases, their documentations, it helps you to get it. Yeah. So how the data dictionary would look like, it would tell you, let's say a student is a table, lecturer is a table, table space is occupied by the users, their status, their degrees, and each and every information about the table, their spaces, the number of fields, yeah, the what the sizes of the fields would give you. So basically this command is giving you the data dictionary. Select asterisk from users table. So this is the data dictionary. So are you clear, in simple words, what the data dictionary is? The data dictionary is the information about the tables. Normally the tables store your information, but the data dictionary stores the architectural information about the table, that what the architecture of the table is. Yeah. So next, advantage. Obviously there is an advantage. It gives a well structured and clear information about the database. Disadvantage is that it should be well designed in advance to take all the advantage of it. The cost of data dictionary will be bit high. Obviously, let's say Emirates website, they need their database to be connected, then it would cost them, yeah, but their cost is worth to invest. But if your company don't want your database to be connected with anything else, would you be spending that much amount on the database dictionary creation?
No.
No. Now, the third and the last topic I will be going through very quickly. Database evaluation. You have to evaluate whether your database is performing well or not. So it includes the performing data validity, data integrity, testing, performance check related to the database, and testing of the procedures, triggers, and functions in a database. Make sense? What is testing evaluation? For example, if you expect that if you recall the example, if there are 100 employees, if you want to search an employee which has a salary less than 10,000 or 10,000, let's say you expect the result, yeah, let's say in 1 second, yeah. If it gives you the result in 1 second, if the database is allowing you to find that particular record in 1 second, then it's fine. But if it took, let's say, 10 seconds, yeah, then you can assume that it is not performing well, isn't it?
That's right.
Yeah. So that's called the evaluation. You need to evaluate your database. So you need to evaluate into different ways, like structural database testing. You need to evaluate the components of the database which are not exposed to the end user. Yeah. So for example, if you have a normal interface, you can search the database, but how the database is internally working, that's the structural database testing. Yeah. So like if the car is being designed, if you can drive, yeah, it drives well, it does not give you a problem. But if the car is safe, is the engine efficient, that's internal. So structural database testing is that. So you can do testing like a functionally check the functionality of the database, and non-functional testing is load testing basically. Yeah. Risk testing, stress testing, the testing minimum requirements. Like I said, for example, if you are searching the database, for example, one database could be connected simultaneously for 10 users. Yeah. Then every user would get the result instantly. But if you are connecting, let's say, 100 users to one database, then you would be testing the load testing. Yeah. And So normally, what you say, some websites get slow. Why they get slow? Because number of people, are accessing to it, they become slow. Yeah. So non-functional testing is basically the load testing, because you are not, testing the database directly, but you are increasing the load on it and you are observing the performance. What is that? That is non-functional testing. Yeah. And functional testing, you are trying to access that particular function and you are seeing whether the function is giving you the result or not. Yeah. But if you are getting the slower result, faster result, that is also called a testing, but that is non-functional testing. Yeah. So make it clear. Functional testing, you check the functionality. In non-functional, you check the parameters, that how well it is performing. Yeah. Then schema testing, it involves validating the object of the front-end application with the database mapping. If you recall, you created a schema about the skeleton of your database that should look like, and then you see how physically those objects are implemented. Yeah. Then stored procedures and views testing. Yeah. So in this testing, a tester ensures that the manual execution of the stored procedure and views generate the required result. Let me tell you quickly. For example, if one query of the database is giving you either, let's say, all records, yeah, of employee, or let's say, one record. But if you want, let's say, six columns out of 10, then how you would be doing that? You would be creating a kind of stored procedures into the database. They would give you, a kind of, a specified number of, attributes. Then triggers are a kind of functions, for example, if you want to create a function, let's say, that would give you a total salaries paid to 10 employees. Yeah. So that particular trigger would be used in order to, give you a help. They would, that would contain a kind of additional code. It would be summing up, the all salaries. So that's about the triggers. So triggers, stored procedures, they are kind of little technical, practical things into the database, but you will be dealing with them when you would create the database. However, their testing is a kind of, the point of discussion here. Yeah.
Yes.
Then tables and column testing, validating the data, what data you can insert into the field and what data the application allows you to enter. For example, if you are trying to enter your name into the seat roll number, then your front-end application should not allow you to enter any letters instead of numbers, isn't it? Yeah. Then database server checks, the server, how the server is handling, how many transactions it is allowing, whether, let's say, if the server is capable to hold or allow, let's say, 10 connections at the at one time, then obviously the server is creating a pool. Yeah, it would be faster. But if you are creating 100 pools to be created into a database server, then you need to check whether it is performing well or not. Probably it could utilize, let's say, more faster if you are creating 10 instances for the 10 users, and if they are created more, then your computer would become slow, isn't it? Yeah. So that's about the database server, configuration. You know well that if you are creating a software, then you are going to, configure it. So database servers are configured as well. Yeah. So if you have configured the server well, then that would be efficient. If not, then it would not. Yeah. So
yeah. Also, and also, can we create a database, say, for example, of two people, say PewDiePie and T-Series?
Yeah.
Okay, just want to make sure.
Yeah. So all these things, were discussed today theoretically, but they have a lots of meaning when you really want to learn the database literally as well as practically, but because this theory is applied to the practical. If you know well, if you take these things in consideration, your database would be efficient and you would prove yourself a good database, developer, architecture. And if you are not considering these things, then, you would be a learner, isn't it? Yeah. So LO3 is complete now, and I would advise you to come up with the, assignments as soon as possible. I haven't received any of your assignments so far, so I don't know what is your position now.
My assignment, like, I'm still working on it. I'm still working on it. I'm still doing some research on my one, so you will be